Hello everybody, my name is Pawan Mehta and you're watching Flow over and Wedge in Ansys Fluent 14 software. So this is the basic layout of Ansys Fluent, Ansys Workbench. So this is the analysis system, this is the error messages you get, this is the properties bar, this is the workspace. Now go to right click. So this is new analysis system, fluid flow, fluent. So you see this geometry, mesh, setup, solution, results. This is exactly how we'll be moving. First we'll be making geometry, then proceeding towards the mesh, then the setup, solution, results. These all are individual components. Geometry is an individual component, the mesh is an individual component, setup, solution, result forms the part of the Fluent software. So this workbench basically is a link between all these components. Data from one is passed on to the other and the other to the other. If you want to start the components, you can do it. You can go to component systems over here, or go to right click and components. You can have the mesh, fluent, Vista, CFD, TurboGrid, whatever you want. You can start the component individually. So now we'll be doing the geometry. So first we'll click the geometry. From 3D analysis we will make it to 2D. Double click on geometry. Starting design modeler. The unit will be millimeters. It depends upon you, it depends upon the geometry. In my case it is millimeters. Select the XY plane and go to this option, look at face, plane and sketch. Sketching, select a rectangle. Okay, done. Rectangle is made. If you have this problem, escape. To save time, we will be doing half analysis. So because the wedge is a symmetric object, so we'll be having symmetry over this axis. Before this, we'll be making the geometry line from here to here. Go to modify, trim the edges. Okay, trimming is done. Now dimensions, lengths and distances from one point to the other. So we have this lengths and distances. This is 0.5 mm. This is 1.5 mm. This is 0.991 mm. And this is 1.259 mm. Let's see, it is still very small. So yeah, this dimension 1.5 0.5, 0.5, 1.991, 1.259. So I've already made the geometry. I've already calculated the geometry for the wedge angle to 15. How much this lens has to be? It is a parabolic. It will be solving a parabolic equation. So the nature of the parabolic equation is such that if any disturbance is at this point, it won't affect the a point before it. It will affect the point after it. So you don't need much of it in the domain. This slant body acts as your wedge. So now concept, surfaces from sketches, sketch 1, apply, generate. So your surface is done. Now take a new sketch. In the sketch, make one line from this point to the vertical. Okay, now go to create, concept, lines from edges, select this, apply. Okay, it is not getting selected. First we make this whole thing as lines. Concept, lines on edges, okay. We have all these lines in here. Now go to concept, lines from sketches, okay. Now I have this line. Now we need a projection over it. Concept, tools, projection. So the edges, this is the edge, apply, target body, select it, this is the target body, apply, generate. So now we have the edge. Now we don't need this line body, suppress it. It should be only in one part. So now the projection is also done, the geometry is done. Now save the project. It is very important that you save the project because it consumes a bit of a high RAM. So if you don't have, if your system doesn't support it, the system will hang and you will lose all the data. Now moving towards the mesh. So we have these two different parts. Mesh. What I will be doing is now I'll be having a very dense mesh around over here. So insert, sizing, edge. For edge selection, click this option, select this edge, apply, number of divisions, make it as 100, okay, bias, yes, this would be 50, reverse it, okay, done. Now one more edge, insert, sizing, select this edge, apply, element size, number of divisions to be 100, bias, factor T. It depends upon you. Mesh, insert, sizing, select this edge, apply, number of divisions 100, bias, yes, and this 50. Reverse it, okay, done. Now insert mapped face mesh, select this face and this one, both the faces, okay. Now generate mesh. As required, we have very dense mesh in here and a bit coarser over here. Have a look. This is what we were expecting when we got it. Now select this edge, edge number 1, 2, 3 and 4. So this will be far field conditions. Remember, Fluent is name sensitive, so while naming it, be aware what name exactly you are giving it. This is symmetry. This is the wall of the edge. Okay, done. Name selection is also done. File, save project. Okay, so the project is also updated. Now proceeding towards the setup, we will use double precision. Okay, so it is a compressible flow, so it will be density based. We will be doing a steady state analysis, and this is okay. So now we will adapt the mesh, adapt to so first we need some initial calculation before adapting the mesh. So once you have calculated, you can go to adapt, then for the gradient, then you can have pressure gradient, then you resolve it, so you will be having a better shock formation. So in this case we are not doing it because first we need to initially solve it. We go to models, energy equation we will be turning on, compressible flow, invested at high speed, the viscous flow are less dominant than the inertia force, so invested. Okay, materials, air we will change it to ideal gas, specific heat is 1.0643, molecular weight is 28.96. okay, change, create, close, boundary condition, pressure far field, edit, mark number as 3, we will be putting it as gauge pressure as 101,325, that is 1 atmosphere. Symmetry is symmetry, wall no slip condition. Okay, operating condition we will change it. This gauge operating pressure is to be 0 Pascal pressure. Okay, codon number will be 5. Solution initialization, standard initialization, far field initialize. Okay, the solution has converged. Now we will proceed towards the results will be filled, display. So you see we have a shock wave in here. This is the pitch boundary and this is the shock. The static pressure, we will can have total pressure also. Okay, so temperature, velocity counter, display. Okay, now we have seen the shock in this case. Now we'll adapt the mesh and we'll see how exactly it is going to gradient, pressure, static pressure gradient. Across the shock, static pressure also varies. Adapt. Yes. Apply. Close. Initialize the solution. Initialize. Yes. Run calculation. 300 iteration. Calculate. In this case we have adapted the mesh. The mesh has changed a bit. The mesh has adapted in a manner to the gradient of the pressure. So before and after the shock, the static pressure variation is there, so will adapt itself. The grid size over there will be very dense, so we'll be having better shock capturing. Okay, the solution has converged. Click OK. Graphics and animation, contours, setup, display. You can see better shock capturing. It has adapted to static pressure. So we see now the static pressure. So if you have the two photos before and after adapting the mesh, just compare it and see the difference. You will see very good difference in here. You see the mesh has become a bit finer at the where the static pressure gradient is very high. Okay, so this was all about the flow over a wedge. Thank you for watching the video. My name is Pawan Mehta. If you have any queries, do contact me. Feel free to contact me. Thank you.